Hello, math friends. Welcome to A Squared Math and Stuff. In this video, we are going to talk about minors and cofactors of a matrix. The first thing we are going to look at is a minor. So how do you calculate the minor of a matrix? Well, first we need to have a square matrix. And the minor is calculated by deleting the ith row and the jth column. So what that means by deleting is we cover up a row, or I'm sorry, cover up a column and then cover up a row. And the values that remain, we are going to work with to calculate the determinant. So let's do a few examples working with this 3 by 3 matrix that we were given. Let's first calculate the minor. So we symbolize M for minor, and then we have to indicate which row and column we are looking at. So I'm going to first indicate row 1, column 1. So we have M1, 1 in here. And what this says is we are calculating the determinant of the numbers that are left over. So if I cover up row 1 and I cover up column 1, or essentially delete them, I am left with 5, 6, negative 5, 6, 8, and negative 9. So I'm going to write those values in the determinant form so I can calculate the determinant. So again, we're covering up those values. So we're left with the negative 5, 6, 8, and negative 9. And we just want to calculate the determinant of this 2 by 2 matrix. So multiply the diagonals. We take the negative 5 times negative 9 and subtract the diagonal 8 times 6. Working that out, we end up with a positive 45 minus 48, or 3, negative 3. Let's take a look at the minor for row 1, column 2. So indicate row 1, column 2. For the subscript, your row is always the first number. The column is always the second number. So again, we're going to go in. We are going to delete or cover up row 1, and then we are going to delete or cover up column 2. So we are left with 4, 6, 7, negative 9. That's what we're going to work with to calculate that determinant. So 4, 6, 7, and a negative 9. Again, multiply your diagonals. 4 times a negative 9 minus 7 times 6. We end up with a negative 36 minus 42, or a negative 78. Let's do then, what about row 2, column 2? Let's look at the minor for row 2, column 2. Cover up row 2, cover up column 2. Can't really see that in there, can you? But once we are left, what we're left with is 1, negative 3, 7, negative 9. So we're going to write those values in this space for the determinant. So 1, negative 3, 7, negative 9. Calculate the determinant again. So 1 times negative 9 minus our 7 times negative 3, and that gives us negative 9 plus 21, or 12. Let's do one more. Let's do row 2, column 3. So row 2, column 3 gives us, cover up row 2, cover up column 3. We have 1, 2, 7, 8. 1, 2, 7, 8. Calculate that determinant. We have 1 times 8 gives us 8 minus 7 times 2, or 14. 8 minus 14 gives us a negative 6. So those are the minors for partial list of minors for this 3 by 3 matrix. So you can create a minor for every single position in this matrix. So we saw 1, 1 has a minor of negative 3. We saw position 1, 2 has a minor. That's negative 78. Position 1, 3 also has a minor. We didn't calculate that. So each one of these positions have their own value for the minor. Let's take a look at a 2 by 2. With a 2 by 2, there's a lot less math going on here, because when we cover up a row and a column, we're only left with one number. So this set of minors would be really quick to calculate. Now, I'll do all 4 of them really quick so you can see it. So if we cover up row 1, column 1, all we have left is 6. Let's do row 1, column 2. So cover that up, we're left with a negative 6. Row 2, column 1, cover up row 2, cover up column 1, all we have is a 3. And then finally, row 2, column 2, row 2, column 2, we have a 5. So these are really quick to calculate for a 2 by 2. 3 by 3 takes a little bit more work, and especially when you get to a 4 by 4, even more work. So the next thing we need to talk about is a cofactor. So what exactly is the cofactor? Cofactors come from, we look at a specific row and column again, and we actually use the minor that we just calculated. And what we do is we take that minor value and we multiply it by negative 1 raised to the row plus the column. So let's take a look at that. I'm going to do the exact same values that I did for these minors. That way we have already calculated the minors, because we need these values to calculate the cofactors. So the first one we calculated was row 1, column 1. So we're going to do cofactor. So cofactor is C, row 1, column 1. And we take negative 1, we raise it to the I plus j. 1 is our I. This 1 is our j. So we raise it to the 1 plus 1. And then we multiply it by the minor value that we just calculated. We calculated a negative 3 for our minor value. So again, row 1, column 1, minor value negative 3, substitute that in here. That gives us negative 1 squared times a negative 3. Negative 1 squared is 1 times that negative 3. So finally, we have a value of negative 3. Let me box that instead of put parentheses around it. So that's our cofactor for row 1, column 1. Next one we looked at was row 1, column 2. So let's do row 1, column 2. So again, this is our I, 2 is our j. We are then taking negative 1 raised to the 1 plus 2, multiplying it by the minor. Row 1, column 2 was negative 78. Plug in negative 78. So we will have negative 1 cubed times negative 78. Negative 1 cubed stays negative 1. Keep the negative 78. Double negative gives us a positive 78. So let's keep going. We have the other two that we did. We have minor 2, 2, minor 2, 3, values of 12 and -6. So cofactor 2, 2, 2, comma 2, -1 to the 2 plus 2 times 12. So we have -1 to the 4th power times 12. We know it's an even power, so that negative turns positive, so we end up with 12. And then finally, the last one we looked at was row 2, column 3. So take -1, 2 plus 3. That value for the minor was -6. We have -1 to the 5th power times -6. Negative to the 5th power is negative, times a negative will give us a positive 6. Same thing happens here with the 2 by 2. Same process. So we looked at all of the minors for this one, but let's just do one of them really quick because it's the exact same process that we looked at up here. So let's take a look at row 2, column 1. So let's do row 2, column 1. We have -1 to the 2 plus 1 times row 2, column 1 had a minor value of 3. We end up with -1 cubed times 3, or finally a -3. So that is how you calculate the cofactors and the minors of a matrix. The next example that I have is how to calculate the determinant of a 3 by 3, and you have to use the cofactors and the minors for this. And I'm actually going to show you a little trick on how to easily and quickly calculate the minors so you have a little bit less math to worry about. So if you like what you saw, hit that subscribe button down below, and I'll be chatting with you later.